We've already talked about the correlation coefficient, but as a quick review, R is always a value between -1 and 1. Values close to 1 imply a strong positive association. Values close to -1 imply a strong negative association. And values close to 0 imply little to no association. That's great, hopefully by this point fairly easy to interpret, but it does leave a pair of lingering questions. The first is, how do we interpret those values that are between -1 and 0 or between 0 and 1? That is, how close does it have to be to -1, or how close does it have to be to 0 before we say it does have an association, doesn't have an association? And even apart from that, how do we know if the relationship that we're seeing in sample data is significant? It could be that the relationship we're seeing in the sample data is due to chance or due to the variability of samples. So we're going to dip our toes back in the waters of hypothesis testing. R, the correlation coefficient, is the statistic that we'll use to make an inference about rho, which is kind of like a P sort of drawn with a little bit of a curl to differentiate it from the English letter P, but this is the Greek letter rho, which represents the population correlation coefficient, which of course we could only know if we had all possible data that could exist on the variables that we're trying to study. In our first three examples, we're going to take a look at setting up hypotheses that we would test based on a given claim. In example 1, a researcher finds a paired data set has a correlation coefficient of 0.8086 and wants to test the claim that a positive association exists between these two data sets. We want to construct the hypotheses to specifically test this claim that a positive association exists. When we set up hypotheses before, the null hypothesis was always a statement of exact equivalence. That's going to be the same here. So we're going to have rho exactly equal to, in this case, 0. Because if the correlation coefficient is 0, that means absolutely no association. That will be our starting assumption, and it will be the same for every hypothesis test we conduct regarding association and correlations. The alternative in this case would be that rho, the population correlation coefficient, is greater than 0, meaning a positive association exists. In example 2, the claim is that a negative association exists with a sample correlation coefficient of -0.6249. This is a great example of one of those in-between numbers. It is closer to -1 than 0, but we're getting into that middle range where maybe it doesn't seem as convincing. So our null hypothesis would again be rho equal to 0, and our alternative hypothesis would be rho less than 0. Since the claim is that a negative association exists, we want to see if there's significant evidence to draw the conclusion that the population correlation coefficient is less than 0. And in example 3, we have a case where the claim is simply to test that an association exists. Doesn't specifically say positive or negative. So our null hypothesis would be exactly the same, but our alternative in this case, since we don't care about specifically positive or negative, would just be different than 0 or not equal to 0.